Supercomputers are used for a wide range of tasks, including scientific research, weather forecasting, and even the design of new products. The development of supercomputers has been a key driver of technological progress, and the race to build the world's fastest supercomputer is an ongoing and highly competitive endeavor. What is a supercomputer? A supercomputer is a computer that has been specifically designed to perform highly complex calculations at very high speeds. Supercomputers are typically used for scientific research, engineering simulations, and other applications that require a high degree of processing power. Supercomputers are made up of thousands of interconnected processors that work together to perform calculations. These processors are often specialized and optimized for specific types of calculations, such as floating point calculations, which are commonly used in scientific research. The race to build the world's fastest supercomputer is an ongoing competition that has been underway for decades. The current record holder is the Japanese supercomputer Fugaku, which was developed by Fujitsu and Riken and was first announced in 2020. Fugaku has a peak performance of 442 petaflops, which means it can perform 442 quadrillion floating point operations per second. Fugaku is being used for a wide range of scientific research, including simulations of earthquakes, weather forecasting, and drug discovery. Prior to Fugaku, the record holder was the United States Summit supercomputer, which is housed at the Oak Ridge National Laboratory in Tennessee. Summit has a peak performance of 200 petaflops and is used for a variety of scientific research, including material science, fusion energy, and astrophysics. China has also been a major player in the race to build the world's fastest supercomputer. The Sunway Taihu Light, developed by China's National Research Center of Parallel Computer Engineering and Technology, held the record for the world's fastest supercomputer before Summit. Taihu Light has a peak performance of 93 petaflops and is used for a range of applications, including climate modeling, aerospace engineering, and drug design. The development of supercomputers has been a key driver of technological progress, and the race to build the world's fastest supercomputer is an ongoing and highly competitive endeavor. However, there are some challenges to building even faster supercomputers. One of the biggest challenges is power consumption. Supercomputers require massive amounts of power to operate, and this can be a limiting factor in their performance. Another challenge is the cost of building and maintaining supercomputers. Supercomputers can cost hundreds of millions or even billions of dollars to build, and the ongoing maintenance and upgrades can be similarly expensive. Despite these challenges, the development of supercomputers is likely to continue to be a priority for governments and private companies around the world. The applications of supercomputers are wide-ranging and include scientific research, national defense, and economic competitiveness. As such, the race to build the world's fastest supercomputer is likely to continue for years to come. The current record holder is the Fugaku supercomputer, developed by Fujitsu and Riken, which has a peak performance of 442 petaflops. However, the race to build even faster supercomputers is far from over. Researchers around the world are working on new technologies and architectures that could potentially lead to even more powerful supercomputers. One area of research that could be particularly promising is quantum computing. Quantum computers operate on a fundamentally different principle than classical computers, which could potentially lead to vastly more powerful computing systems. While quantum computing is still in its early stages, researchers around the world are working to develop practical quantum computers that could one day outperform even the fastest supercomputers. Another area of research that could be promising is neuromorphic computing. Neuromorphic computing is a type of computing that is inspired by the structure and function of the human brain. By using hardware that is specifically designed to mimic the neurons and synapses of the brain, neuromorphic computing systems could potentially perform certain types of calculations much more efficiently than classical computing systems. There are also ongoing efforts to improve the efficiency and power consumption of supercomputers. Many researchers are exploring new materials and architectures that could potentially lead to more energy-efficient supercomputers. Some researchers are also looking into novel cooling technologies that could help to reduce the energy consumption and cost of operating supercomputers. Despite the challenges of building and maintaining supercomputers, the potential benefits of these systems are vast. Supercomputers are essential tools for scientific research, weather forecasting, and a wide range of other applications. They are also important for national defense and economic competitiveness. As such, the race to build the world's fastest supercomputer is likely to continue for the foreseeable future. One potential application for supercomputers that is gaining increased attention is their use in the development of artificial intelligence, AI, and machine learning, ML systems. These technologies have become increasingly important in a wide range of industries, from finance and healthcare to manufacturing and transportation. Supercomputers are uniquely suited to the development of AI and ML systems because they can process vast amounts of data and run complex algorithms with high precision and accuracy. This has led to increased interest in using supercomputers for tasks such as image and speech recognition, natural language processing, and predictive analytics. In addition to their potential for advancing AI and ML, supercomputers are also being used to tackle some of the most complex challenges facing humanity. For example, researchers are using supercomputers to study climate change and model the behavior of complex systems, such as the Earth's atmosphere and oceans. Supercomputers are also being used to develop new materials and drugs, simulate the behavior of nuclear weapons, and study the properties of subatomic particles. These applications have the potential to transform a wide range of industries and have a significant impact on society as a whole. However, building and maintaining supercomputers is a complex and expensive undertaking. Supercomputers require specialized hardware and software, as well as sophisticated cooling systems and other infrastructure. They also consume large amounts of energy and can generate significant amounts of heat, which must be managed carefully. As a result, the development of supercomputers requires significant investment and expertise, which is often provided by governments and private companies. The competition to build the world's fastest supercomputer is not only about achieving a technological milestone, but also about securing national and economic advantages in areas such as scientific research and national defense. In conclusion, the race to build the world's fastest supercomputer is a complex and highly competitive endeavor with significant implications for science, industry, and society as a whole. While the development of supercomputers presents many challenges, the potential benefits of these systems are vast, and their impact on society is likely to continue to grow in the years to come. Thanks for watching our video about the race to build the world's fastest supercomputer. Supercomputers are crucial for scientific research and national defense. The competition to build the world's fastest supercomputer is vital for securing national and economic advantages. If you enjoyed this video, give it a thumbs up, subscribe to our channel, and hit the notification bell to stay updated on our latest videos. Thanks again for watching.